Yeah, I mean, the reason why I was asking was because I'll be traveling on Wednesday, by Wednesday evening. So next week we have two options. Either we can skip the class on Wednesday if you guys are traveling. I mean, if you guys are not around, or else we can do it on Tuesday evening if that works for everybody. Yeah, let's do it on Tuesday evening, okay? So that way at least we have some continuity, right? Yeah, because the SAT class on the weekend I'll be missing because I'll be in a remote place and taking class from there would not be a great idea. So yeah, let's make sure that we do the class on Tuesday so that at least you guys have continuity with this one. All right, so I'm not sure if anybody else is going to join, but regardless, we'll get started. Okay, starting the class. All right, so today we wanted to, as I had sent the message in WhatsApp group, today we will learn laws of sine and cosine. Now, before I start talking about it, does anybody in this group know what exactly those are? And it's okay if you don't know. I mean, that's fine. I mean, that's why I have an opportunity for teaching, but I'm just curious. Have you come across these laws? Something called law of sine or law of cosine?
No, sir.
Okay, that's good to know. At least I'm not going to waste your time. And again, even if you know, when we talk about things, obviously, you'll not be wasting your time. But yeah, if you are starting afresh, Arya, how about you? And Dev, beta?
I haven't heard of it, but maybe it might be a similar concept.
Yeah. So let me put the formula on the screen. A by sine alpha equal to B by sine beta equal to C by sine gamma. How do you write gamma? Let's say. Okay, I'm just putting something. Have you seen an equation like this? No? Or an equation like a squared equal to b squared plus c squared minus 2bc cos theta. Good. I'm talking about something which is coming from an unknown place. Is that true? Yep. All right. So let me not keep stretching this. So let's talk about it. Now, when you talk about something called laws of sine, what it means is if you have a triangle, any triangle, okay. Let's say you have two angles known. Let's say this angle and this angle. Let's call this as angle A and let's call this as angle B. If you have these two angles known, and let's say one of the side, I will call this is going to be, let's say this is going to be C. So the side opposite to this, I will call this C. Side opposite to this, I will call this A, and side opposite to B, I will call this as B. Okay. So these are three sides and these are three angles. Okay. So in a situation like this, for any given triangle, if you know two of the angles and one of the side, then you can find out everything else about that triangle. And I'm not saying this is a right angle triangle. I'm saying this is just a triangle where you know two of the angles and one of the side. This could be this side, or this side, any side. Okay. So if you know two of the angles and one of the side, you should be able to determine every other property. When I say every other property, I am saying you are just putting one other side. You can figure out what the value of other two sides would be and what value of the third angle would be, which anyways you can figure out. If you know two angles, third angle will be 180 minus sum of these two. So finding the angle is fine, but determining the sides is something that law of sine says. So this says, let's say this is my angle A, so, and my side opposite this is A, so A divided by sine of angle A will be equal to B divided by sine of angle B will be equal to C divided by sine of angle C. This is what law of sine says. Meaning, here if you see, you knew, let's say this side, and you knew these two angles. So here you know angle A and you know angle B. So these two angles and this side, you can fit in this formula and you should be able to find out what the value of B would be. Similarly, you can look at this angle and this angle, this side and this side, fit in this formula, look at these two combinations and you should be able to determine. So that's what the law of sine says. Is this part going well so far?
Yes, sir. I understand it.
Okay. Now, you will say, why would we believe that you are giving me some formula out of the blue and saying that, remember this. This is not something to memorize, this is to understand. If you remember in previous classes, if I would have told you guys that the sides of the triangle are in proportion to the angles. Meaning, if this is a big angle, the side opposite to that will be a bigger side. Let's say if you're looking at this angle, and this angle is bigger, then the side opposite to this will be bigger than the side opposite to this angle. This is something that I have told you guys. This is one level beyond that. So so this is just a formula, okay? This is called law of sine. But again, there is no law that we abide by unless we believe in that. So we'll work on figuring out the way to believe that law, okay? But before I go trying to prove it, quick question to everybody. Dave and Rehan, are you guys with me? Have you understood what I have told so far?
Yes, sir.
Rehan? Yep?
Yes, sir.
Okay. Now forget about this law of sine for a little bit, because you don't want to believe your teacher if your teacher forces you to memorize things, and you should not. I mean, you should not believe any teacher, be it me or anybody for that matter, who says that this is the formula, memorize this. That is not the right thing. Now, let's try looking at it. Let's say this is my triangle, A, B, C. Let's say this is my angle. Let me keep it simple, okay? This is my angle 1. No. This is my angle 1, which is with A, okay? With the vertex A. This is my angle 2, which is with vertex B. And this is my angle 3 with the vertex C. So far simple, easy.
Yes, sir.
Now, if you had to believe and let's say this is my side A, small a, okay, which is opposite to 1. This is my side small b, which is opposite to this, and this is my side C, which is opposite to angle 3. So if a law of sine is to be believed, then the formula would be A divided by sine of 1 degree, whatever this angle is, sine of angle 1 will be equal to B divided by sine of this angle, sine of, okay, let me put this formula in the corner of the board so that we have some more real estate to deal with. So A divided by sine of this angle, A divided by sine of angle 1 will be equal to B divided by sine of angle 2 will be equal to C divided by sine of angle 3. This is what I'm just keeping for a reference, okay? So that when we try proving this, at least we'll be able to validate against that. Yeah? Now in this triangle, let's not worry about anything. I'll just drop a perpendicular from the vertex. And let's say this meets at point D. So far so good? Yep. Now let's look at this is the perpendicular I've drawn from the vertex, okay, which is meeting at point D. Now let's say this height is maybe h. Yep. If you look at this triangle, when I'm looking at triangle ABD, this is a right angle triangle right now. You guys agree? Because I've drawn a perpendicular, and I'm talking about this angle. Yeah, the one I have shaded right now. Yeah. So this is a right angle triangle. When I've drawn a perpendicular, this small angle that you see, which is shaded, which is a right angle triangle. And in a right angle triangle, this is my angle 2, and we know that from the SOHCAHTOA rule or whatever you call it, right? The basic trigonometry says that h divided by c, h, which is the side opposite to this angle, h divided by c will be sine of angle 2. Yep. Is everybody with me so far? I just need one yes, okay? So that I can confidently move on.
Yes, sir.
Okay. Now, again, I'm just repeating myself. I have a triangle. This is side, this A, B, C. The side opposite to vertex A, I'm calling it as A. Side opposite to angle B, vertex B, I'm calling as B. And side opposite to vertex C, I'm calling it small c. Okay? This is small c. Okay? And I have given the name as this is angle 1, this is angle 2, this is angle 3. As per the sine, laws of sine, this is what we are trying to figure out if this holds true or not. So what I did was, from this vertex, I have just drawn a perpendicular here, which meets at point D. So I'm looking at the small triangle ABD, which is now a right angle triangle because I've drawn a perpendicular. So in this right angle triangle ABD, if I want to look at this H, which is my perpendicular from this vertex, or the side opposite to this angle, H divided by C will be sine of this angle. Everybody with me? That means H will be equal to C into sine of angle 2. So far it's all simple, looking simple, right? No? Dave? Arya? Nothing complicated so far, right?
I understand.
Okay. Now, so in this triangle, we have just tried, see I'm saying this is my height h, and h divided by c, if I'm looking with respect to this angle, h divided by c will be sine of this angle. Okay. Now let's look at this blue triangle or the red triangle, which is this one, which is this is angle 3. Again, h is the vertical line which is making 90 degrees here. So if I talk with respect to this angle, again this h divided by b, this height h divided by b will be sine of this angle, will be equal to sine of angle 3. So from this also we can determine h equals b times sine of angle 3. B times sine of angle 3. We got one value of h from this triangle as c times sine of 2. C times sine of angle 2, and from this triangle we found h equals b times sine of 3, angle 3. Everybody with me so far? So I can happily agree that c into sine of angle 2 is equal to b times sine of angle 3. B times sine of angle 3 coming from here, which is h, and c times sine of angle 2 is coming from this equation. Yeah. Now bring the sine, make the sine move this way. So if you do that, c divided by sine of 3, angle 3 is equal to b by sine of angle 2. C by angle of sine 3 is equal to b by angle of sine 2. Yeah. So just a quick recap. Okay. It might sound little cryptic to begin with, but I did not do anything fancy. Okay. I just took a triangle without any classification to it. It's just another triangle. I'm not saying whether it's an equilateral triangle or isosceles triangle or scalene triangle. It's just a triangle which has all three sides which are different, and not a right angle triangle for sure. Because we are trying to find out the geometric formula. Took a triangle, said okay, this is my side, these are my three sides, and from one of the vertex I have drawn a perpendicular on the other side, and then broke this into two right angle triangles. Found out this height applying SOHCAHTOA. So this height will be equal to c times angle this. So sine of this angle will be this by this. So that is how we got this value. Similarly, we took the second triangle, and then with respect to this angle, we looked at sine of this angle will be equal to this divided by this. So we found value of h, which is common in this triangle and this triangle both, and then we compared them to find out one part of the equation or one part of the law of this laws of sine. Are you guys able to follow what I said? Is this relatable? Are you with me? Okay. So, same way you can play around and you can pick this as a vertex and from there draw a perpendicular, and then you can find out the other part of the equation also. So, after all this we have done so far, we can agree to the point that laws of sine is not something which is a forceful act of the teacher to convince you guys. There is something that you guys have seen how it works. So that's why hereafter you can use this as a mechanism for solving problems faster. If you have any triangle A, B, C, this is alpha, this is beta, and this is gamma. I think some gamma. I don't remember the sign. How you write gamma? Let's see if this looks like this. Okay. So, and this is side A, this is side B, this is side C. Yes, Arya. Yeah, go ahead.
Wait. Oh, never mind. I read that wrong.
So,
I understand.
So from this, we understood that this side divided by the sine of this angle applying to this side, sine of alpha, will be equal to this side divided by sine of the angle applying to this one, sine of beta, will be equal to c, this is small c, c divided by sine of, I'm kind of struggling to recall how do you write gamma, okay? So I'm just writing this as g, okay? So this is what is law of sines. What is the advantage of this? this applies to any triangle when you're dealing with a situation when you know two of the angles and one of the side. You should be able to find out all other sides or the properties and its value. That is how it helps. Now you can use that for solving different problems. Let's say you say that, okay, you are, let's say, flying a kite. I hope everybody knows what is a kite, okay? So you are flying a kite and the length of your string is, let's say, 40 meters. And right now your kite is making an angle of 30 degrees with the ground. Okay? And you have a tree here at this point. Assume the height of the tree is not much. What is the angle at which you can see the kite from this place? And you can relate that with any kind of practical problem, right? Let's say there's a helicopter flying here which is making 30 degrees from this place. If there's a radar which is trying to trace this guy, at what angle should that locate that helicopter? It could be any problem. Net, what I'm saying is, if you know this point and this point, if you know the distance between these 2 points, or you know this point and you know, so basically here law of sine helps you when you know two of the angles, and you can relate it with any problem. I'm sure when you do some unit test you'll be able to relate it. Practically, if you in any given triangle, if you know two of the angles and one of the side, you should be able to use the law of sines to determine every other property of the triangle. Make sense?
Yes, sir.
Now, when I was teaching you guys this thing, and I again made a small attempt to confuse you guys, which I always do. I was saying that this situation, you know this length, this distance, this length of the string you know, and you know this distance, and you know this angle. Law of sine might not help. Or law of sine will actually help because you know two of the sides. So you can always pick the two sides. One of the angle is known, second angle you should be able to find out. Yep. So this also works. But there is one more law which says law of cosine, and that helps you solve this problem with an alternate approach, which is a little tricky one. Okay. So it's called law of cosine. It's not law. There's only one law. Law of cosine. And now I'll say, which says a square equals b square plus c square minus 2bc cos of theta. And this might look little scary to begin with. Again, it has nothing complicated in it. It simply says if you have any triangle and you know two sides, let's say this side and this side, and you know the angle between them, okay, then you should be able to find out this length. Let's say this is B and this is C and this is your angle theta. You should be able to, you can apply law of sine to obviously find out any of the other angle. If you know the two sides, obviously you can apply the law of sine to find out the other angle and correspondingly find the third angle in the sides. But in another way, you can also apply law of cosine to determine this. So if this is B and this is C and this is your A, this side and this side are known to you and this angle between them is known to you, you should be able to determine this side, which goes by this formula. A square, the square of this side will be equal to square of this side and square of this side minus 2 times BC of this angle between them. Or if you, let's say if you pick this as a theta, then it will become C square, this one will be equal to B square plus A square plus 2AB into cos theta. So again, might look little cryptic, but remember this, Any third side that you have to determine, if you are given two sides and the angle between them, it will be the value of this side will be equal to square of this side plus square of this side minus 2 times this side and the cos of the angle between them. Since you have a cos theta here, that's why it's called law of cosine. Are you guys able to digest this formula so far before I try proving it? Okay. So one thing we learned was law of sine, which says that side divided by the sine of the angle opposite to the side are in the same proportion. That's what law of sine says. Law of cosine says if you have two sides known to you and the angle between them known, then the third side, square of the third side will be equal to square of the two sides as addition of the square of two sides minus 2 times multiplication of the two sides times the cos of theta. Okay? Interesting one? Difficult one? Scary one? How is it?
I get it.
Sorry, beta?
I get it.
You got it? But does it look scary or looks okay? And you guys don't have to be shy, okay? It's fine. I mean, you can tell your teacher what looks scary. So that is where I can put that effort for getting the scare out of it, okay? Alright, so this is the formula. This is law of cosine. And why would you believe me? Let me make you believe. So, if you, again same thing, I'm pretty much predictable, not very complicated person. I will do the same thing like what I did before. Let's say this is A, this is B, and this is C. This is my triangle, and no classification. I'm not saying whether it's an equilateral triangle. Let me just say that this is a scalene triangle. Okay, that means there is nothing that is known to you. Everything is different. All the sides have no correlation with each other. Okay, apart from the theorems or the formulas we know. And let's say this is angle 1, or let me say this side which is opposite to this one, which is C, and this side which is opposite to this one, which is B. Okay, and let me see, this is A. Okay, fine. Let me not confuse you guys. Okay, this is ABC. Okay, and this side is opposite to this one. I'm calling this small c. Side opposite to this one, I'm calling it small b, and side opposite to this, I'm calling it small a. What is known to us is this and this angle. Okay. So what is given to us in a triangle? I know this side and I know this side and the angle between them, which is theta. So if the law of cosine is to be believed, let's say this is going to be b. Okay. So b squared will be equal to a squared plus c squared minus 2ac times cos theta. Yeah. Now let's look at it. So as I said, that I'm very much predictable, so I will not do anything different this time. Same, I took a triangle. I said, okay, this side is known, this side is known, this is my theta. Let's draw perpendicular again. Okay. So when I draw perpendicular here, let's say this meets at point B, and from here to here, let's call this height as h. So again, by drawing the perpendicular, I have split this into two triangles. Yeah, two right angle triangles. Now let's look at this triangle. Triangle ABD. Okay. Let's look at what is the length of this one BD. From here to here, I am saying it is A. Okay. Now, what is this length from here to here. And this is probably, let's find it out. So this is h, and this is, okay, so this is, let me call it BD only, okay. So this BD, if I'm looking at this right angle triangle with respect to this angle, cos of this angle will be BD divided by C. BD divided by C will be equal to cos theta. Are you guys with me so far? Yeah? I'm looking at this triangle ABD. This is my height h of the perpendicular. This length, I don't know what is it. We just know that this side is part of this whole side. Okay, this much is one part of this side that we see. So less than a, we'll figure it out. So this BD, I'm relating that with respect to this theta that we know. So BD divided by this side C is cos of this theta for this triangle. Yeah. That means I can say BD equals C times cos theta. Yep. And also if you want to look at this H divided by C will be equal to sine of theta in this triangle. Yeah. Okay, before I move on, let me just do a quick recap of what I have done. I have a triangle ABC. This is my side opposite to this vertex A. I'm calling this whole length as A. This is opposite to my vertex C. I'm calling this a small c. This is opposite to my angle B or vertex B, which is, this angle is theta, and I'm calling this length as B. Okay. I have just drawn a perpendicular from here to here. It meets at point D. So I'm looking at this right angle triangle ABD, and I'm saying, okay, fine. What is my length BD? BD is nothing but BD divided by C will be cos of this theta. So I'm saying BD divided by C is equal to cos of theta. So BD equals C times cos theta. That's what I've said. Yeah. Now, again, same thing. H divided by C. If I'm looking at this triangle, the shaded one. Okay. H divided by C will be sine of theta. Agree? So that means H will be equal to C times sine theta. Yeah? I'm not doing anything fancy, okay? So this is the side. I'm trying to relate this side with respect to cos theta. This by this will be cos theta. And I'm trying to find out this length, H divided by C is my sine theta in this triangle. So that's what I put here. So I found the length of this guy as C of cos theta, and this height H as C of sine theta. So far, not complicated, right?
I understand it, sir.
Okay. No, so see, my confidence comes from you guys, okay? If I don't hear a confirmation from or acknowledgement from one of you or each one of you, my confidence starts shaking, okay? So that's why I'll keep on checking in between, okay? So in this triangle, we found this H and we found this BD. Now, look at this whole length. This BC from here to here is A, my whole length. So if I have to find out this part here to here, now I'm going to switch to the next triangle, which is the red one. Okay? So this is also right angle triangle. So I'm talking about triangle. I'm talking about the red triangle ADC. In this triangle, what is this length? DC. This DC is nothing but this length minus this length. So this equals A minus this length, BD. BD is nothing but C of cos theta. Okay. And what is this length? H. H is nothing but C of sine theta. Okay, C times sin theta. A minus C cos theta. C cos theta. Yeah, Anjika.
Hi, sorry I joined so late.
No, I get that. That's okay. So, how much time do we have? We still have 25 minutes. So, today we are learning law of sine and law of cosine. Okay. So, I'll do a recap. Okay. So you will not.
Oh, it's okay. I'm doing that in school right now, so I'm pretty caught up. So
Okay.
I think continue.
Anyways, so whatever we are doing, I mean, anyways, I'll do a recap towards the end, so that way you'll be able to relate and make sure that you're not missing something. And if there's some confusion, you have the video at your disposal any which way. Alright.
Okay, thank you.
So now looking at the second. So right now, Anjika, we are trying to prove that law of cosine, okay, which says b square equals to a square plus c square minus 2ac into cos theta, and where in summary what this law of cosine says that if you know two of the sides, let's say this and this side, a and c, I'm calling this side as c and this side as this side as a and this side as c. So what this says that, and this is the angle between these two sides that are known to us. So square of this side plus square of this side minus 2 times this side and this side times cos theta equals square of this side. That's what this says. So right now, what did we do? We picked up a triangle, gave a name to all the sides. This is A, B, C. Side opposite to A is, this side is A. Side opposite to this one, I am calling this a small b, and side opposite to this one, I am calling a small c. So what we are trying to prove is c square plus a square minus 2 times c and a times cos of this angle will be equal to b square. So I have drawn a perpendicular from here to here, which meets a D, and we looked at this black shaded triangle, and from this we found that cos of theta will be equal to this length divided by c. This length BD divided by c will be cos theta. So BD we got as c of cos theta. Similarly, this h, the perpendicular that we have drawn, h by c will be sin theta equal to sin theta. So h by c equal to sin theta. So we found h as c of sin theta. Now we came to this triangle, the red shaded one, and in that one we again found that h is the value coming from here, which is c of sin theta, and this length is nothing but this length minus this length. So this length is a minus this length, which is c of cos theta. So a minus c of cos theta. A minus c of cos theta. This is what we have got. So now there is nothing fancy to be done. We will just recall what we know as Pythagorean theorem, which says in a right angle triangle, square of this side plus square of this side will be square of the hypotenuse. That means square of this is nothing but this. So square of this, get a square of this, and get a square of this will be equal to square of this. That means b square, this square will be equal to this square plus this square. What is this square? This square is this one, will be equal to a minus cos c cos theta square plus this square, which is c sin theta is square. So we have to just break this down and see what it translates to. So here if you look at it, I'm just going here, taking this equation here, which says b square equals a minus c times cos theta square plus c times sin theta square, which will be equal to c square into sin square theta. Okay. Now break this down. This becomes a minus b whole square, that is a square minus this square, plus this square. A square minus 2ab, so 2 times a times c cos theta plus c square cos square theta. So a square minus 2ab plus b square plus c square sine square theta. Now these two things you can club together. So this becomes a squared minus 2ac cos theta plus these two things together, where c square is common, sine square theta plus cos square theta. This value is 1. Sine square theta plus cos square theta for any theta, any angle, sine square theta plus cos square theta is always 1. So from this, what we got was a square minus 2ac into cos theta plus c square into 1. So that is a square minus 2ac cos theta plus c square. Now, all that I was doing, it was very simple. Though I made it look complicated, which I always do. Our main objective was to understand why this formula is to be believed, which is called law of cosine, which says that if you know two of the sides and the angle between them, there is a relationship or there is a law which says how you determine the third side. So if you have two known sides, so square of this side plus square of this side multiplied by 2 times the two sides and times cos of the theta will be equal to the square of this side. That is what we have to prove, and this is what we got. Oops. Yeah. So this b square equals a square plus c square minus 2 times a into c times cos of the angle between them. And how did we prove it? Simple, we took a triangle, have drawn a perpendicular here, looked at one right angle triangle, from this we found this height and this length in terms of cos theta, and used this height and this length. We determined this length as this length minus this length, which is this one. And this length we found, and we applied the Pythagorean theorem. That gave us this equation. So, like I always do, I will just summarize this. Okay, there are two things that we learned today. One is called law of sine, and second one is called law of cosine. And what it says is, if you know some of the properties of a triangle, you should be able to apply these laws to find out rest of the parameters or rest of the properties. Like in the case of law of sine, it says a divided by sine of a will be equal to b divided by sine of b will be equal to c divided by sine of c. What it means is sine divided by the sine of the angle opposite to that will be equal to next side divided by sine opposite to the angle of that. It will be equal to third side divided by sine of the angle opposite to that. There also, just to do a recap, this is what we did. We picked up any random triangle. We said, okay, there are the three angles, and let's say this is the other sides. We just dropped a perpendicular from the vertex on here and found out this in relationship with this angle. Okay, and then again try to find out the same this one in a relationship with this triangle, and then we compare them, and in this case we used again. So we just dropped a perpendicular from here. We looked at this angle and found out this height, and then in the second right angle triangle we used again same this height with respect to this angle, and then we related them. So that is basically, if this is h, we found h divided by c equal to sine of this theta. Let's say this is beta. This is angle b, right? This is angle c. So h divided by c was equal to sine of b, And from when we looked at this triangle, we found that h divided by b is sine of c. And from we found out the value of h and we compared them, it gave us this ratio. Okay. And in case of law of cosine, same thing, it says any side which is unknown, square of that will be equal to the known sides squared minus 2 times the multiplication of the two sides times cos of the angle between them. And same thing we did, picked up a right angle triangle, dropped a perpendicular. This is the known angle, this is the known side, this is the known side. Found out this length and found out this length in terms of cos theta, and then this length is known, so found out this length as a subtraction between this length minus this length, and this length as a sine of this theta, and applied Pythagorean theorem to prove this one. So that is a summary of how did we prove law of sine and law of cosine. Any questions you have which I've injected, please let me know with respect to the concepts before I move on. I know Anjika, you joined a little late, but as you said, you are pretty much caught up. So still, depending on whatever you have learned and whatever I explained here, if there is any doubt, please let me know.
Yeah, of course.
Rehan, Arya, Dave, are you guys with me so far?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
I mean, it's relatable, right? Nothing confusing. As long as you remember one thing, that you have to draw a triangle and drop a perpendicular. In case of sine, you will keep the two, since you have two known angles, you will find out h value with respect to this angle and h value with respect to this angle and compare them. That gives you the ratio. You should be able to prove it. And you don't really have to prove it. This is more of a method to make sure that we are not memorizing it in a forceful way. We understand what actually happens behind the scene. What you will end up using is this. This is a formula. Whatever I was doing was to make sure that you get convinced about the validity of the formula, right? Because doing math is much easier. Okay, I mean, if you even if you forget this formula, right? One thing you would remember that the side and the sine of that is in same proportion. Side by the sine of that is always the same proportion. So depending on whether you know two of the angles or whether you know two of the sides. If you know two of the angles, you will apply the law of sine. If you know two of the sides and the angle between them, you will apply the law of cosine. And in real term scenario, this will come out very handy, because you'll be dealing with problems where you have a triangle where only some of the properties are known. If somebody says this is this side and these two angles are known, find out rest of the sides. If I would have not been knowing this formula, it would have been difficult for me to figure out how do I get other values. But once I know that, okay, if I have one side and two angles known, I have a magic formula that I can apply to determine everything else. Imagine not knowing this formula, then trying to figure out all the three dimensions, and you might be able to find out this angle, but nothing beyond that. Yeah? Make sense? Doesn't make sense.
It makes sense so far, sir.
So far, okay. There is a hope that will make sense in future also. Let's spend some time to solve at least one problem. Okay, I want to see you guys getting your hands dirty, and this is part of Unit 2, Lesson 6, where you will find law of sine, law of cosine in the Khan Academy, and that is where I would want you to do the unit test and the practice questions. That will give you the confidence, and that will make me also confident that you guys have understood. And in case you struggle, you have to let me know so that I will kind of try peeling up the onions further. Okay. So now there is a word problem which says two kids are playing, okay, and they are making their kites fight. So these are the 2 points. These two kids are 40 meters apart. This kid's kite is flying at an angle of 45 degrees. Okay. And the length of the string is, for this first kid, is 30 meters. What is the angle of this kid's kite has to be at, and the length of the string to kind of knock off this guy. So essentially what I'm saying is, you know this side. So again, I'm repeating my question, okay? Two kids are in a playground being 40 meters apart, flying kites. One kid's kite is at angle 45 degrees and the length of the string for the kite is 30 meters. Other kid is who is at 40 meters apart. He's trying to knock off this guy's kite. At what angle he has to fly his kite and what has to be the length of the string to be able to knock it off. So I did not say law of sine, law of cosine. I just gave you a random problem that two kids are trying to knock off each other's kite. One kid is flying at an angle 45 degree. Second kid doesn't know what angle he has to fly his kite and what has to be the length of his string to be able to knock off this guy. And knock off this guy's kite actually. So I want you guys to try it and let me know what the answer would be and why. And more importantly, I would want to hear your approach as well. So you guys have maybe 5 minutes. Are you guys game for trying it?
I can try it, yeah.
Yeah. You guys understood the question, right? Everybody? Anjika, Dave, Rehan?
Can you repeat it one more time?
Okay. So two kids are flying kite in a playground. Okay. And they are 40 meters apart. Okay. One kid is flying his kite at angle 45 degree and the length of his string is 30 meters. Now for this guy to knock off person A's kite, he is trying to determine at what angle he has to fly his kite and what has to be the length of his string. This is a word problem that I have made on the fly. You guys understood the question, right?
Yes, sir.
Anjika, Rehan, Dave?
Yeah, that makes sense.
So try solving it. And even if you guys are not able to solve it in the class, I certainly want you guys to think and let me know what would be your approach. How would you go about solving this problem? What would go in your mind first? I mean, more like a blueprint. Yes, sir.
I would think whether to use sine or cosine for the angle inside.
Okay. And what would be your conclusion after looking at the question here? What is the scenario we are talking about? So just to give you guys a clue, okay? Now, when you have a situation, okay, I'm again not forcing you guys to memorize this, but more of a conclusive approach. If you are, look at a situation where you have two sides and the angle between them known, cosine is your best bet, okay? See, this is AI, sorry. So, when you look at two sides and the angle between them, cosine is your best bet. If you are looking at one side and two angles, law of sine is your best bet. Now here, since you know the two, see, ultimately when you look at the question, you are seeing that, okay, you have two sides known and the angle between them known. What you are trying to find out? The third side and the angle. So first of all, how would you find out the third side? Your cosine formula says square of this plus square of this multiplied by 2 times this into this and the cos of the angle between them. So let's find out this length first. So what is the length of the string? Let's say this is C. So C will be equal to this square, 30 square plus 40 square minus 2 times 30 into 40 times cos of the angle between them, cos of 45 degree. Now 30 square is 900, 40 square is 1600, minus 2 times 30 into 40, 12 into 2400, into cos of 45 is 1 by root 2. So square of this gives you this value, and then once you determine this value, get a square root, that gives you C. So from that you will find out the length of C. Now how do you find the angle? That is where law of sine will come into picture, because now you know the sides, you have to find out the angle, and then you know, if you know the side, let's say this angle you have to find out. So this angle by this side, let's say this angle is theta. So this side 30 divided by sine of theta will be equal to, this angle is known, so sine equal to that you found this out. Let's say this is C, whatever was the calculation, okay? So this length divided by sine of 45 degree. Again, you know sine of 45 is 1 by 2, whatever value comes from here. So this will give you sine theta will be equal to 30 times sine of 45, which is 1 by root 2, divided by this value of C, whatever it is. Let's say whatever it is, C. C is some value which is derived. So in this one problem, we saw the possibility for using law of sine, law of cosine both. We used law of cosine to find out the length of the string, and we found an opportunity for finding out the this angle by using law of sine. Yeah? Make sense?
Yes, sir.
So, in terms of approach, again, same thing. When you hear the question, read the question, you are clear about what the question is, then you start thinking, what exactly do you know? Then you will recall that, okay, I know law of sine, law of cosine. My law of cosine will help me determine this length, and my law of sine will help me determine this angle. So that's how you will go about it. So with that being said, I'll take a pause and see if you guys still have any question for me before we go.